you know, to complement what we've already learned about the 7 series storage, what I'm going to do now is I'm going to, let's say, go into a quick overview of storage and what the more modern concepts in regards to storage would be, things you need to know. I'm going to probably be quite fast because obviously we have a lot to cover in the last day and a half, and we've got quite a bit more to get through. But it'll be over about, some of it might be a bit repetitive, but I will try and keep it interesting, and I will try and not put you to sleep straight after lunch. Strategy, we'll have a bit of a storage product portfolio, few solutions from the customer. Once again, the integrated stack message, you've seen it. You're probably blue in the face with integrated stack at this stage, but the company likes to get this message across. Now, basically what we're talking about, what's happening in the data center and where are we going, okay? Traditionally, what we would have had was single tier of disk storage. Then we had, let's say, multi-tiered disk storage, what the cost was. And now we have, let's say, modern multi-tiered storage, okay? So for instance, up here, remember we were talking about tiered levels of storage. When we talk about our pillar device, we'll be getting more into it. But basically, the tiered level of storage means basically people integrating and, let's say, organizing their storage in such a way is that the information that they need most and accessible most and virtually instantaneous is stored in the most efficient way possible. So they utilize the most modern means. So for instance, flash storage, really fast, quick database transactions. They would store their information up there in flash. So basically, our storage products are now integrating different technologies within the storage array itself to tier the storage to suit the needs of the application or whatever is accessing that storage. So for instance, you might, let's say, have your redo logs for a database, for a fast transaction, for things like this, high-speed transactions. For instance, let's say high-frequency trading would all be stored up in flash. Because it's the most modern, it's obviously the most expensive part of the storage per gigabyte. So it's an average of about $40 to $54 per gigabyte at the moment. Possibly, you know, you'd see that, let's say, coming down quite quickly. Then the next one now, we've got regular disk. We've got, let's say, 7,200 or 15,000 disks. This is the second level, okay? Next level will be capacity disk, bigger disk. So we've got 3 terabyte disks now that we can put in some of our storage arrays, okay? And then the next one we've got is tape storage. Now the idea with this tiered storage, for instance, when somebody is designing their solutions, when somebody is putting their, let's say, storage together, they think intelligently as how the data is accessed. So for instance, let's say a bank account, let's say Visa, for instance, how would they store the customer's data? Excuse me. A 3-year-old Visa bill is going to be put on tape. What's the likelihood that a customer is going to want his Visa bill from 3 years ago? Okay? They will not have it on flash because nobody's ever going to access it. Okay? Right? So for instance, that gives you the idea. But let's say I want to know what hit my Visa bill yesterday. I potentially could put it on flash. Okay? Or I want to know what's happening in my account today. I'm waiting to see if I got paid. Let's say it would go in and the transaction would be stored within the flash storage. Okay? So this is pretty much a good analogy. So let's say what was up until now, or a methodology, let's say, different, let's say, ways and means of, let's say, organizing your storage. But the point, or an important point about this is that the way data is growing is vastly outstripping IT budgets, okay? Because of, obviously, videos, because of, you know, other mediums that people are storing content, okay? So what is our, let's say, here are some of our storage products, okay? And where does it fit in? Oracle's, let's say, tiered storage. We're missing, let's say, our pillar devices, which we'll be talking about later on this afternoon. But we'd, let's say, online or nearline. We've got primary, that's your primary storage, that's mission critical. For your high performance apps, what you'd, let's say, use flash storage or hybrid storage devices. Okay? Remember when I was talking about Exalytics machine, fast transactions, really fast, in-memory machines. So for instance, high frequency traders and people like that. Okay? So what are the devices we'd use? where would you use it? Now this would be more, let's say tape storage would be more for your, let's say, archive stuff. Video, medical data. Remember we were talking before about medical data. Regulatory compliance and disaster recovery. Secondary storage, fixed content, backup and recovery, business continuity, and we want to take a snapshot or a mirror image very quickly. Okay, we've already talked about things like ZFS. Here's, let's say, where the tiers of storage come into play. Average day since creation, 0. So we want second recovery time. Seconds to 30 plus days, 90 days to forever. So think of it like, let's say, a jet airline. This is your super expensive business class. This is your, let's say, middle. This is, let's say, the pardon? Higher economy. Yeah, this is the not exactly economy, and this is coach here at the back. Okay, if you want to, let's say, think of it as a jet engine flying through the air. Sorry, we had that. So what's the storage vision? Customers are going to accelerate performance and lower IT costs by using business-ready storage systems. So they're going to use complete business systems that integrate business application software with tiered storage for optimum performance, efficiency, and scale through the Oracle stack. Okay. So obviously we'd already talked about engineered systems. Remember I was giving you a bit of the big boy, the Exadata machine. That was the first one. Now we've got a thing called Exalytics. Okay. Exalytics is for, let's say, your middleware. So your WebLogic would sit on the Exalytics machine. Okay. So they're engineered to be technically superior, business-ready tiered storage devices for application software for performance. So it's the best of breed tiered storage infrastructure. Yeah.
So the Exalytics is acting the same as the Exalogic, but smaller machine? Because I know that the Exalogic is for...
Sorry, Exadata. I meant Exadata. Sorry, apologies. Did I say Exalytics?
Yeah.
Correction. Exalogic. It's been a long day and a half. Well spotted. We can make these mistakes. Exactly. Exit. So if it's got exit, it means fast and very, very scalable too. Really enterprise-wide machines. Okay. Apologies. Well spotted. For dock warehouse. So where are we using these machines? This is the storage and the hardware, all combined software. So for dock warehouse, for data warehousing applications, run data-intensive query processing storage in the storage grid. 10 times compressed tables. Remember HCC? This is going to be what your Exadata machine is. Okay? Best of OLTP, online transaction processing. It's the only database that scales for real-world applications on grid. It's got smart flash cache. 20 times the performance, 20 less fewer disks because of the compression. Okay, and because within this we've got the InfiniBand connections, so it's really fast. It interacts between itself, the application tier, the database tier, because of these InfiniBand connections, which are very, very fast. Best for consolidation. It'll scale and run to all workloads. So for instance, you can get this, remember we talked about the ODA device in our ODA session. So the ODA comes up to about here, and then maybe up about here we've got what's called an eighth rack. Then we go to a quarter rack, and we go to a half rack, and then we go to a full rack. So that's where these, I hope this is kind of coming together insofar as I say the ODA, where does that fit in? Where a customer can, let's say, pitch this sort of device to meet his commercial needs. So it's from the smallest business with, let's say, 100 employees to, let's say, the US military with 2 million employees. Oh, whoops. So here we are now, we're going to our product portfolio. Sorry, take these away because these are incorrect. But what we have is we have on this side we have our Exadata, Exalogic. Okay? Remember I was talking about the web tier, the middleware. Okay? Our 7 series family. We've got flash storage. We've got fast connection cards that we can put into our storage and into our servers. This is an F20. We've got an F40 card out now. We have a flash array, which is an F5000. So it's just a flash device. It's a smaller machine. Okay? Then we have our pillar storage. Then we have our tape storage here on this side. So this is the whole family here, okay? And what do we do? Enterprise software. So we're going from advanced compression, analytics, replication, deduplication. We have our ZFS, hybrid storage pools. The list goes on. Crypto key management, ASM for Oracle. Okay? So basically, whatever you want. Okay, very, very quickly, I'm just going to show you. People have asked what was Oracle's strategy since we took over Sun, and they were looking for some sort of roadmaps. And here's a roadmap for you to, let's say, share with your customers. The moment through to 2015. Obviously, they're developing these technologies. So when we're talking about a 15 times, 12 times, 32, 50 time, these statistics here on the right-hand side might change. Who knows, they might change for the better. They could change for the worse. However, this is where we see as a, let's say, a roadmap into where and how our Oracle storage is going to scale to meet the needs for computational I/O in the next two or 3 years. Okay, so obviously, guys, you can ask me some questions, but this is what the developers and the people who are writing, who are architecting these sort of appliances and this sort of storage and stuff, this is where they see themselves going with the current, let's say, developments in technology coming from universities, research, and things like that. So that's where the trajectory of the storage is going. And this is, let's say, some of the characteristics of what we've got. Flash storage, interconnects, file protocols, data services, disk storage. What sort of capacity do we have? So that's the product line characteristics. Here we have, let's say, technology advantage, unified storage, our fiber channel arrays, our flash storage, best data protection, only with triple parity RAID and 128-bit file system. It's the lowest risk. So when do we, let's say, use our unified storage? When we're looking at storage consolidation, bulk storage, disk-to-disk backup, collaboration. What's the business value here? Reduce storage costs, increase business agility. Okay? These are some of the innovations which is driving the business value. For instance, flash at the moment is becoming more and more important within storage. Okay? So upskill yourselves on let's say, flash arrays and things like this. But obviously, this is quite technical, guys. So leave these conversations to your pre-sales assistants, okay? So guys like me, or guys like your counterpart Hussein, get him on the phone and talking to your customers, okay? That's pretty much the way you want to really position this. He's the specialist. Oh, and by the way, Hussein, as far as I know, would be very, 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 very good on storage, because I think his background is from storage. So you've got you have a specialist there. So you have actually a storage champion working for him, and he should be giving this.
We told them to come.
So we're going to talk about flash storage. Flash storage integrated with our software, which is automated to use flash. It's very, very dense, so we can get it into one rack unit. We have the most comprehensive portfolio of flash storage. So what does flash do? It improves the application performance and reliability. And one big plus of flash is it vastly reduces power consumption. You're going to think flash is like there's no moving parts in flash. It's just electrical current. So you don't have, let's say, a disk spinning at 15,000 RPM or at 7,000. Think you got an array with, let's say, 60 disks in it. You got 60 spinning components at 7,200 or 15,000. All of a sudden, what does that mean to your electricity costs? What's to your power costs? What does it mean to your AC costs? You keep all those spinning components cool and at the temperature within which they're supposed to function. It's a tall order and it's an expensive price in regards power consumption. Remember, these are conversations you should be having with your customer. And flash appears to be changing the IT landscape at the moment, guys. Flash, otherwise you might hear them referred to as solid state drives. Okay? It's already enjoyed explosive growth. And its growth's going to continue through 2015. Unless there's something on the horizon 2015, I would say through 2017, 2018. I haven't heard any. Has anybody else heard of any major innovations in fast storage? No? Okay. So IT managers, sorry?
Expensive as well compared to.
It is an expensive solution. At the moment, yeah. But obviously as economies of scale and people can, let's say the producers can leverage economies of scale, flash, in my opinion, will start to replace moving disks over the next, how many years? 15, 20 years.
Disk becomes obsolete and
Exactly.
becomes cheaper.
Yeah. So as more people take up flash, the price will drop. You know, IT managers found they can significantly reduce their IT spend while increasing throughput by replacing enterprise hard drives, the old regular hard drives, with a technology that initially appears to be much, much more costly. Okay? And now look at this, 50% of the hard disk market will no longer exist in 5 years. And none of it will exist in 10 years, except in museums. I was actually doing an implementation in the UK a few years back, and it was at a BT managed exchange. So there was British Telecom would have been the people who originally had it. So they had actually a hard disk drive from 1974, and I think it could have been about maybe 8 meg or 16 meg. Anyway, it probably took up half the desk, and it probably weighed about 80 kilos. It was that size. Okay, so if you just think the size of flash now, and you know you can get 4 gig, 8 gig memory sticks, 8 gig memory sticks this size. Okay, there's an underlying complexity that needs to be addressed. The question of managing data on and off SSDs and onto storage tiers. Remember, I was talking about the storage tiers, the plane. Who's in the front and who's at the back? How do you manage your storage? And 11G is the first optimized database for flash. So our flagship database, DB2 doesn't optimize itself for flash. Microsoft SQL doesn't optimize itself for flash. Okay? And have we got a management system? Yes. For a ZFS management system is optimized to utilize the flash that is within the system. Okay, here's some, let's say.
Flash can be connected to both the storage and it can also be connected to a server?
Yeah. Depending on how you configure the flash, that's like literally another, let's say, discussion you'll have with your customer in pre-sales. Okay? So here we're looking at, let's say, some of the reductions. I don't need to go into these slides. You guys will be receiving delivery of these slides, but they're fairly self-explanatory. Okay?
SLC and MLC. I've heard of that term before, I'm not sure what that means. I know there are different types of components could we sell also. The part numbers differ by that.
So where are we talking here, is it?
SSD, SLC, MLC.
I'm not sure. SLC, let me think, SSD. Solid state disk MLC. Multi-layered connections, maybe. Possibly. But here's, let's say, where the prices are being reduced, okay? But as you can see, it's still, flash is still, in comparison to 15K or 7,200 drives. But the IOPS, obviously, IOPS are more expensive, so the throughput is more expensive, okay? But the gigabyte bit, but the IOPS here, it beats it. Let's look at it. It's to the tens of thousands faster than your regular disk. And look at how many, let's say, gigabytes per watt, as opposed to this. So when I'm talking about the spinning, you can see it's literally the power consumptions, the power savings are quite considerable when you engage flash. So when when somebody is kind of going, no, it's too expensive flash, remember this, okay? Remember these slides. Software, hardware complete. Smart flash cache, advanced compression, partitioning. We have our F5000, F550 flash array. We've got F20 and an F40 card now, okay? We've got solid state drives. We've got our ZFS storage. We've got our complete engineered system with the Exadata and the Exalytics and the Exalogic machine.
5100 is
Yep,
storage array.
it's a storage one. It's a flash array,
And
exactly.
F20 goes into the server.
Yes.
Can you move a little bit?
Sorry.
And F20 also goes into the storage.
Yeah,
Oh,
it's the same card. They just put it in there
any
twice.
storage or only Oracle storage?
Sorry, I've got to check out what, but if the F20 can, let's say, sit into storage. It might just be a server option. Okay, I have to check that out. I'm not sure. But this is, let's say, where we would let's say leverage the beauty of Flash. Here's a quick look at our F series storage array. Very, very fast. So what's the equivalent of 3,000 disk drives in one RU? You can get up to 1.92 terabytes of flash storage. It only uses 300, accelerates database performance twice, and reduces your energy consumption by 100 plus times. Upon the conclusion of our rigorous internal testing requirements, the Sun Storage Flash Array reduced our total database operation times by an average of 4 times and power savings by up to 4 times. There's a quote for you from Thomson Reuters. Okay? So run your database twice as fast. This is a bit of an older slide. I don't particularly like it because it's Oracle 10G, which is the precursor to 11G. It's still supported, but I'd say as soon as 12C starts coming out, we'll see 10G going away. Okay? You can see here we got the older Sun logos on this sort of a thing now. So we have a comprehensive flash storage portfolio. Any questions, guys? Accelerate your application, reduce your operating costs.
So basically all the database customers.
Excuse me?
Yep,
In the middle. Flash,
I'm in the way again.
Flash modules, do we sell that also? No. We just sell those two.
Well, we sell, okay, sometimes, yeah, okay, we do in some cases. I'm not exactly sure which ones.
What is a flash module?
I don't know.
It sits into a server.
What's
So-
the difference between the F20 and
This is a card that sits into a PCI slot. If let's say, okay, on some of the servers we have, let's say, areas for memory modules. Now they could be meaning DDR3 memory here also, right? Okay, so that's where I'm unsure. Do they mean DDR3 memory when they're talking here, or is it, let's say, another module that can sit into one of those servers? Okay, this sits into the PCI bus. Okay.
And even storage has PCI, right?
Sure, it has the PCI standard, yeah, but storage is kind of different. It's like, you know, if you want server, you buy server for things like host bus connectors and stuff like that. You wouldn't necessarily have a PCI bus. It might use PCI 2 technology, you know what I'm saying? But we might, I mean, when we sell our storage, we basically sell it insofar as it's a modular system. So you get a tray of disks to upgrade and increase. So we wouldn't really work with it within the, I think that what you're alluding to here. You know what I'm saying?
Maybe we need to see those boxes in real to see.
Exactly.
And maybe you could take us a tour of the data.
Data center. The next time we'll have a tour of the data center.
The next time I will be there.
So here's a comparison versus flash versus disk. Number of drives, power consumed, drive reliability.
what's 2.25?
I just want to say, I think this we've got a bit more coming up here. Let's look.
What's 2.25 AFR?
2.25.
First line on drive reliability.
Failure rate. Average failure rate. So what they're saying here is that 15K disks are actually also for failure because they got moving components. There's a higher failure rate within 2.5, sorry, within 15,000, 7,200 RPM disks than there is with flash
Do,
because there's less moving parts.
yeah, the flash memories, flash cards that can you swap them on running?
Are they hot swappable? Not yet. Not yet. I think with innovations, maybe latest innovations with Solaris soon, but will the operating system, will the let's say whatever the storage array address memory increases? For instance, if you swap out a card, I think that functionality is either with, let's say, Solaris 11, okay, as from an operating system point of view, or it's very close there. It's certainly in progress, hot swappable, addressable. Okay, so where it doesn't need a reboot is basically what you're asking. Can I pop a flash card in now?
Need a reboot, and if there is
I don't know.
And the loss of data on it, will it be, if it's not swappable, you have to remove it, will it be restored?
The operating system will take care of that. But obviously there's a command sequence that's going to be run through if you were going to do something. But it is close there. So I'm sure if they were to, let's say we've got a hot swappable flash pieces, what the operating system would organize to happen would be that the information that's residing on the card in memory will be migrated somewhere else to secure it. For sure, they'd have to take that into account. That will be a feature, hot swappability. So we're going to start talking about unified storage. I'm going to quickly go through, quick overcap of ZFS, and then we're going to move on to our pillar systems. We had this morning. Here's just another. The 7720 has gone away. 7420 was seen as the adequate full rack option when you needed ZFS, when you needed a 7 series storage appliance. Obviously, there's a different slide again when we're talking about our competition. Oracle versus what does the NetApp go? I remember I was talking to you about the hidden costs. For instance, a lot of times you're going to come across the IBM model of licensing things which we give out for free or which comes with the machine.